X and Soyoung, and we will be dealing with number 4. So the question asks, let f be a function that maps a complex plane to complex plane, and this will be a holomorphic function. And the modulus of f of z is equal to c, which is a constant for all z in the complex plane. And we have to show that f is constant on the complex plane. So we know that the modulus of f of z is c, and we can describe f of z as equal to uxy plus I times vxy, where uxy is the real part of f, and vxy is the imaginary part of f. And since we know that the modulus of f, which is c, is equal to the square root of u squared plus v squared, we got rid of the square root, and therefore we get c squared is equal to uxy squared plus vxy squared. And we took the derivative respect to x and y, respectively, and we get that after you take out the 2, since the derivative of c squared is the derivative of a constant number, we can get 0. And for the derivative in respect to x, we get 0 equals to uxy times ux plus vxy times vx. And for the derivative in respect to y, we get 0 equals to uxy times uy plus vxy times vy. Now we use the Cauchy-Riemann equations because we know that f is holomorphic. The Cauchy-Riemann equations must be true. And we replace all the ux and uy into the v's. So we get uxy times vy plus vxy times vxy times vx equals to 0 for the first equation, and then you replace the uy with negative vx using the Cauchy-Riemann equation, and you get negative uxy times vx plus vxy times vy is equal to 0. And then we took the second equation and we solved for vx. So when you solve for vx, we took the second equation. So we did that, and you get vx isolated. Now you plug in the vx that we isolated from the second equation. We plug that into the first equation, where you can see it up here. That is uxy times vy plus vxy times vx equals to 0. And you plug that in, and then you get uxy times vy plus vxy times v over u times vy, which is vx equals to 0. And you simplify, and you isolate the vy. And as a result, you get vy is equal to 0. And because the Cauchy-Riemann equations apply, you get ux is also equal to 0. And you can do this for the other one, where you take the first equation, solve for vy, and get vx equals to 0 and uy equals to 0. Or you can just plug this value of vy equals to 0 and ux equals to 0 into this equation that we isolated, where vx equals to v over u times vy. You'll get the same thing. So as we got the zeros for all the derivatives, we know that since f prime of z is equal to 0, f must be constant, because the derivative of a constant is 0. So there was number 4, and thank you for watching.